Okay, so first, I want you to remember long division like from whatever grade you do long division in. I don't know, 3rd, 4th, something like that. You're right. So let's say we were doing something like 8,532 divided by 7. So first of all, I want to point out that when we write down numbers in our number system, there's a number in every spot. Meaning if this was 8,502 and we didn't have the 30, we would have a 0 in the 10 spot, right? So we're going to do this with polynomials later, but that idea that we automatically put a 0 in that spot when we do stuff with numbers is going to carry over to where we have to put zeros in when we're doing stuff with polynomials. So think about what you do when you do long division. You try to get as close to this as possible, right? To kind of take out things in the thousands, hundreds, until you get just down to the 1 spot. So we would ask ourselves, what times 7 gets us as close as possible to 8? So 1, good job, all over it. Sorry, my computer's like slow. She's like, I'm ready for this. Okay, so then we get the 7, so because 1 times 7 is 7, and then we subtract those quantities. So it leaves us with this remainder of 1 in this spot, and we bring down the term that's in the next spot. Okay, and then we do the same thing again, and we just keep doing this process. So what times 7 gets us as close to 15 as possible? 2, 3. So 7 times 2 is 14. Sorry, my pen is like not working well. And we subtract, and we get a remainder of 1. And then we bring down the 3, and what times 7 is going to get us close to 13 as possible? 1. 1 times 7 is 7. 6. We bring down the 2. 9. So 9 times 7 is 63, but we go over. Yeah, so it'd be 8. Be nice. Okay, so then when you were really little, you learn this, and then you just learn that that means the 6 is like the leftover. Like there are 6 ones left over, and you just write something like remainder 6 or something like that. So that vocabulary is important to us. Like there's a remainder. Okay, remainder means leftover. But the way that we write it is going to be more. I thought you were handing me the drink. Bribery. No, I'm just kidding. Okay, so now when we write the remainder, we're going to write it more like we did once we understood fractions. That instead of just telling someone there's 6 left over, it's more informative to tell them there's 6 left over out of 7, because that tells them you were really close to almost having a whole nother one, right? Whereas if there was 6 left over out of like 92, that wouldn't be very close to getting another one, okay? And so then we end up writing this as like 1,218. Yeah, it will work. And then 6 out of, okay? I know my pen is not working good. I apologize. All right, so do we get this idea? Do we remember the division process? 6/7, yeah. And that's really 1,218 plus, write the plus sign with what we do today when we have a remainder. So what we're going to be dividing is stuff like this, okay? It actually works a lot like that. There are some other things, and it is more difficult, but it does work a lot like that. So the first thing I want to look at is that we don't write polynomials. We don't write polynomials like we do numbers. Meaning, in polynomials, if there's a spot we don't want, we just don't write it. For example, see how we had x cubed, and then we don't have any x squared? And then we have x, and then we have 3. If this was a number, and that was like the hundredth spot, and we just didn't have any hundreds, we wouldn't leave it blank, because then we wouldn't have the right number. We'd put a 0 in that spot holding it. So if you're going to do division and you want everything to line up properly, you want to do what we do with numbers. You want to have a 0 in any spots to hold their spot and line them up properly. So we're going to think of this as x cubed, if I can get this to work, plus 0x squared plus 2x minus 5. It's not that you couldn't do it without that, but it's that if you did do it without it, you would eventually have things that were not like terms lined up together, and you might be tempted to combine them together just trying to get through the process, and you might mess something up. But if you put zeros wherever something's missing in between different powers, you'll always get all the x squareds lining up together and all the x's and all that kind of stuff. Okay? So then just like division, our job is to figure out what times this equals this, but that's a little overwhelming for our brain to think about at first. So like division, we kind of want it to go this way. We want to get it down to the constant. So in order for that to happen, that means we want to start canceling out the highest degree terms, the things that have the highest powers of x's. So to make that happen, what we're going to do is we're going to specifically choose what we would want to multiply by this to match at least the very first term. So in other words, what do you want to multiply by this to get an x cubed at the beginning? So what times x would make x cubed at the beginning? X squared. So I'm going to choose, oh, batteries are low, that's why. Sorry, it's very annoying. Okay, so I'm going to choose x squared. Now when we choose x squared, okay, so I chose it so the first one would match. Then remember what you did with long division. Whatever you put up here, you multiplied times what was right here and wrote it underneath here, right? Now when you multiply, that means that x squared is multiplying this entire thing. So it has to multiply both pieces of it. So the x squared times the x is going to give me x cubed. And the x squared times the 3 is going to give me 3x squared. And then in our division algorithm, what operation do we do between these things right here? Subtraction. Now, we have to be careful. Remember when you guys subtract polynomials? Just real quick, you've done similar in weekly reviews when you plug some stuff in. If I have something like x squared plus 2x minus 3, and then I have minus x plus 5, you guys normally do this so that you don't make a mistake since you're subtracting all of this, is you basically distribute the minus sign to each of those, right? And so this basically becomes a plus, and you're saying this is negative and this is negative, and then you combine the like terms. Okay? So that's what we're going to be doing here. Maya? Yes. So I multiplied this times this as well as this, and I got these two things. Is that okay? So I'm going to subtract all of this. But remember, subtraction really means adding the opposite. So that means I can think of it as addition if I change each of the signs of these things here. And if I did this correctly, if my division algorithm is going to work out, remember we said we want to cancel things of highest degree until we get down to the constant. We should see that these cancel out, which in this case they do. And then I have a 0x squared plus a negative 3x squared, so that leaves me with negative 3x squared, and I drop down my next term. Because once you've distributed the negative in here, you shouldn't leave a negative out here still, because that'll make you think you have to distribute it again. Yes? So are you always trying to eliminate the term on the left? Yes. Just like so that it goes like it does with division. Where you are, like how you... Yes. Okay. The other parts don't matter as long as you're eliminating that first term. Okay? All right, so now we have a new place, and just like with our long division, that means we start over the process. In other words, what times x will make exactly negative 3x squared? So negative 3. And then how many powers of x? Because we're going to multiply it times x. Just one power of x. Okay. And then again, I take that and I multiply it. I know, it's just weird. I take it and it's not working right now. And I multiply it times each thing here. So negative 3x times x would make negative 3x squared. Okay. And then negative 3x times 3 would make negative 9x. And then I'm supposed to take those things and subtract them. Okay? So again, subtraction means if I'm going to distribute that negative to each of those, to think of it as addition of the opposite of what was originally here. Okay? And then we should see the first terms cancel out. Okay? And then in this case, we'll have 11x. And we'll drop down the minus 5. Okay? And then you start the process over again. So what do you want to multiply times this over here so that you can make 11x? 11. We already have the one power of x. So we would choose 11. Okay. And then I multiply it through to each of these I distribute. So 11 times x is 11x. 11 times 3 is 33. And then remember that I want to use the operation of subtraction with these, okay, which is like adding the opposite of each of these once that negative is distributed. So again, this cancels out like I wanted. I get negative 38. At this point, I'm done. Here's how I know I'm done. What would I multiply times x to get negative 38? It would have to have like an x in the denominator, and that's not okay if we're dealing with polynomials. Okay, we would want x to have only positive powers or no power at all. but not like negative powers, not when x would show up in the denominator. So that's how you know when to stop, is when this has a lower degree, a lower power of x than what you're dividing by, because then you can't make that happen. Okay? So how we would write our answer. So the answer to this divided by this is x squared minus 3x plus 11, and there's a remainder of negative 38. Okay, but remember, we want to write our remainder with, it's this much left out of whatever we were dividing by. So we have 38 left out of x minus 3. I know it's kind of weird because it has an unknown value. And I'm actually going to make it a negative, not because it will always be subtraction, but because the 38 was negative. So instead of writing plus a negative 38, I'll just make it a minus sign. Okay? Is this okay with everybody? Yes?
Okay. I got lost off in the second part. What do you multiply x plus 3 by?
Right here?
Yeah, I should get that.
The negative 3x. So this was negative 3x squared. So I asked myself, what would I want to times by x to make negative 3x squared? So I chose negative 3x. So it's basically like once we get this new line, we start it over again to get that first part to match each time. Just like each time we brought something down in the long division, we said, now what would I multiply 7 by to get this number? It's the same idea here. Okay, Joey?
Why is it denominator next to 3?
Because that, oh, sorry, it should be x plus 3. Thank you. Should be whatever I was dividing by. So in this case, plus, I apologize. Thank you for catching it. Other questions about this? Now, how many of you have seen long division before? Okay, some of us. So here's the deal. If you've seen pre-calc, you've seen long division. If you were in Algebra 2, some teachers taught it, some teachers didn't. They don't technically have to teach it anymore. Okay? How many of you guys have seen synthetic division? Okay, so we're not, So for our purposes, our goal was not really to teach you division, to be perfectly honest with you. We want to graph rational functions. But part of doing that involves sometimes having to divide. So given that it's not always for sure in the Algebra 2 curriculum, we have to show it to you guys, right? Or else how can I expect you to divide when some people, it's not expected that you knew it, okay? So a lot of you know it. We're not going to do synthetic because sometimes we have to divide by x squared. So those of you that know synthetic division, if you know it and you know how to use it well, you're welcome to use it when it's allowed, okay? And it's basically, you can use it when you have x with 1 as the coefficient and 1 as the power. But if it's x squared or if it's 3x, you have to do modifications before you can do that, okay? All right, so we're going to look at one other problem where we have to use some fractions because I know that you guys don't like them, but we do have to get used to them because the numbers don't always work out all perfect, okay? So we're going to do one other example. So notice in this one, it's written a little bit differently, but the fraction bar, remember, means divided by, right? So this really means top divided by bottom. So the polynomial in the numerator, what's in the top or the numerator of the fraction, is not missing anything, meaning I don't have to put a 0 placeholder. Its highest power is 3, and then it goes 2, 1, and then the constant. So it's already all has something for each spot. So I don't have to put a 0 like I did last time in, okay? And then we're dividing by 2x plus 1. So the process is the same. The numbers are just going to be a little more difficult this time because there's a 2 here. It's not, unless everything worked out even every time, it's not always going to be a whole number that we can times by to get the number that we need. So I just want to make sure that when it's not the whole number, we still have an idea of what to do or how to figure it out. Okay? It might not be simple, but you guys have enough number sense to be able to do it, even if you have to do work off to the side. So the first one's okay. What am I going to multiply by 2x to get 4x to the third? 2 and then x squared. Okay. So I'm going to distribute that through this whole quantity. Okay. So the first term would be 4x cubed, and the next term would be 2x squared. And then like we said before, I'm going to subtract that, which means adding the opposite. So these cancel, and I get negative 5x squared. So here's where it gets a little more complicated. Okay? Normally, if we were just using numbers in division, we would say, well, 2 doesn't go into 5, but I can get close, I can get 4. In this case, though, that's not going to help us, because the problem is we can't finish the division unless we can cancel out this term. So in our division, it's okay to choose a fractional value, because it's more about the x powers getting to cancel out. So we can't have fractional powers on x, but we can have numbers in front of x that are fractions because we need to match this exactly. Okay? So some of you already know in your head what number you're going to times 2 by to get 5. That's perfectly acceptable. Some of you are like, I'll never know that number, Ms. Dahl, so I just won't do this problem. But basically, the question I'm asking you in words, if you're not sure, turn it into a little mini problem that you're doing on the side. So I'm asking you, what are you going to times by 2 in order to get negative 5? So there's something that you're going to multiply by 2, if I can get this to work, to equal negative 5. Okay? How would you get this alone, this a that I wrote here? Divide by 2, because it's not being added with 2, it's being multiplied by 2. Which means the number that I would want to use is negative 5 over 2. Negative 5 over 2 when multiplied by 2 would give me negative 5. So if I can't figure it out, but I know the sentence I'm trying to solve, that sentence is a math sentence or an equation that you can eventually figure out. It'll just take a little more work. So I'm going to use negative 5 over 2 so that I make the x squared. Okay? Now again, if you have to do work off on the side, it's fine. You are now going to take that negative 5 over 2. Yeah, don't really know. Negative 5 over 2x, because the batteries are low, but I don't have any more. And you're going to multiply it by 2x plus 1. Okay? Yes? Would it be okay to subtract like a fraction of decimal? Yeah, you can write it in decimal form if you want. That's fine. So this is going to times this. Okay? And when that happens, the 2's will cancel out. And we'll be left with negative 5x squared. That's what we wanted. And then it will multiply this, and that will give us negative 5 over 2x. Okay, so this is what I'm getting when I multiply that stuff out. Those of you that don't have to do the work on the side, you don't have to do the work on the side. But my point being, if you think you can't do it because it's not automatically floating into your head, go do a little scratch work and then figure it out. Okay? So when I multiply this times this, I got negative 5x squared. And then when I multiply it times the second term, I got negative 5 over 2x. Okay. And then, like we said before, we're going to subtract these quantities, which is like adding the opposites of them. So the first one's cancel. That's what we wanted. And again, some of you might feel here because there's a fraction. So then you're adding 1x plus 5 over 2x. So they're like terms. They both have x. You're going to have an x. In order to add them together, you need common denominator. So this is 1 over 1, but I really need it to be a denominator of 2, which happens by timesing by 2. So I'm going to think of it as 2 over 2. So that means when I add these together, I'll keep the denominator of 2, and 2 plus 5 will give me 7. Okay? So I get 7 over 2x. And then I'll bring down the minus 6. So this is 1, but it needs a common denominator with this to be added together. So I want this denominator to be 2. If I times the denominator by 2, I need to times the numerator by 2. So I have 2 over 2. Then once your fractions have common denominators, we keep that denominator and we add the numerators. Okay? All right. So last one, again, a little bit complicated. Okay? So I'm going to come over here, write a new little number sentence to help me figure it out if I don't know. So I'm asking myself, what can I multiply by 2 in order to get 7 over 2? Okay. So some of us might know that off the top of our heads. Others of us don't. So what could I times by 2 to get 7 over 2? Either we know or we write down this, what times 2 equals 7 over 2, and then how do we figure out the a thing here? How do you get a alone in this equation? Divide by 2. Good. Now, some of you then hate this because you have 7 over 2 divided by 2, and you're like, I don't even know what that is. Write it out like you used to in elementary school. The batteries are really not going to work here. 7 over 2 divided by 2. That's the same as 7 over 2 times 1 over 2. So that is 7 over 4. Okay? Again, some of you are fast like Ms. Dahl, I don't need to do that. Fine. But those of you that are like, I don't know how to do it. If you can add and multiply fractions, you can do it. You just have to do work off on the side. Okay? So I'm going to choose 7 over 4, based on my work there, to be what I'm going to multiply this stuff by. So I already know 7 over 4 times 2x is supposed to give me this. I'm almost done. Just finish. And then 7 over 4 times 1 would be 7 over 4. And we're subtracting this, so we're going to change the signs. So that cancels. Thank goodness we're at the end, so our fraction work is there, but this might look a little bit scary. But it's okay. So do negative 6 minus 7 over 4. Okay. So in order to subtract fractions, what do you have to have? Common denominator. Right now, 6 has a denominator of 1. If you want it to be 4, then it has to get multiplied by 4, so that it's 4. And if this gets multiplied by 4, then it's 24. So we have fractions with a denominator of 4, and in the numerator, negative 24 minus 7 will be negative 31. Yeah. So now how to write our answer. So we've already talked a little bit about it. So we're going to have 2x squared minus 5 over 2x plus 7 over 4. And then we have this remainder of negative 31/4. So don't freak out that it's a fraction. Since it's negative, I'm going to subtract. It's 31 over 4. But then we're also supposed to put what we were dividing by in the denominator with it, right? That just means it goes in the denominator here with the 4. Okay? That's it. And if you want to multiply the 4 through and call it 8x plus 4, that's fine, but you don't have to. Okay? All right, so like I said before, Mr. Sock gave his class like 30, and I gave you guys 5 division problems. Okay?